how we can be more sustainable in the future. And then our second speaker is Howard Wertheimer, FAIA, who is Executive Vice President and Chief Operating Officer with the Piedmont Park Conservancy. Howard's past experiences with Georgia Tech as the Assistant Vice President for Capital Management, and he was later promoted to Institute Architect, where he oversaw the campus master plan, including the Candida building, which we're going to hear about today. So I don't want to take up any more time with my introductions, and I'm going to go ahead and suggest that we move on to our two speakers. And just as one final note, in case I forget at the end, we are going to send you wonderful speaker gifts in the coming week. And so if you're interested, our speaker gift that is going to be coming to you, Anthony and Howard, is a book called The World of Three Zeros: The New Economics of Zero Poverty, Zero Unemployment, and Zero Net Carbon Emissions. And I'm going to buy myself this book too on Kindle today because I think it looks fascinating.
Oh, Dan, don't do that. I bought it for you too.
Oh,
I bought 3. I didn't tell you that. I bought 4 of them. I got 1 for myself.
All right. Well, thank you for that, for letting me kind of give you a little introduction here. But I'm going to go ahead and suggest that we go ahead and Velma let Anthony share his screen, and we go ahead and hear from Anthony, unless you have something else you'd like to add, Bill.
I think Anthony should be able to do that already. He is designated as a co-host as well.
Okay, thank you very much, Dan. Thank you for inviting my business partner, Andrew Waugh, to speak to you, and apologies to those who don't know he had a family emergency today and has asked me to step in. Now, I'm just gonna try and get this right. Is this, excuse me, sorry. Am I getting this? Have we got this?
Yes.
Fantastic. Okay, so I'm not entirely sure what the brief is to discuss today, but Andrew and I like to talk about what we do quite a lot, and we have quite a few talks. So hopefully this fulfills the brief. If you feel me going in the completely wrong direction, do feel free to interrupt. So this is an adapted talk that I put together for. We like to think of what we're going through at the moment as a construction revolution. I'll talk to you about that more shortly. These are my comrades in the revolution. As you can see, we're all mad about timber, and in particular cross-laminated timber, which Dan mentioned. We used to start with a slide like we'd start with this slide, but thought we didn't have to do it. But I didn't realize, Dan, so we've talked about it so much, we don't realize that CLT is still very novel to a lot of people. So it does what it says on the tin, and that it's big boards of timber made up of planks laminated in perpendicular layers to create massive construction boards. You can see in my background a building under construction. And the point about it is every kilogram, every meter cubed that we use in construction, we're storing permanently 600 kilograms a ton of CO2. And of course, this has, for us, this is the kind of key driver for this for us, the triple carbon saving. We have the carbon absorbed during the growth of the timber, which is then harvested when the timber's matured, the trees are matured, and leaving space for more growth. Removing the need for concrete and steel, high polluting, high energy, high embodied energy materials, and more importantly, actually driving this reforestation, which is going to be, I think most people acknowledge, just, you know, of all the technologies available, planting trees is one of the key ways in which we're going to address climate change. So, I mean, a lot of the work that's been going on in buildings since sort of the 1990s, which is when kind of the issue of carbon emissions was seemed to be first addressed in construction, globally have been on the operational carbon, driving down cost of heating, lighting, cooling. But only very recently have we started to talk about embodied carbon, the carbon based in the structure. And where you have, this is a sort of simplistic graph showing that it takes, in a large building, it can take up to 25 years before the savings in operational, the carbon impact of the operating costs is greater than that of the fabric. And of course, when we look at the target we now have, which is only 10 years away, we really need to be addressing this embodied carbon. So as Dan said in my introduction, we stood our first CLT building in 2003, but our key work was Murray Grove, built in 2008, 2009, which is the world's first tall timber building at 9-story. All the entire structure and the external walls, lift cores, all constructed from CLT. And this moved the material from being a niche product for kind of schools and low-rise into something that could compete globally with concrete and steel for high-density urban buildings. And within the last 10, 12 years, we've completed about 20 other buildings of varying scales, and now have about 20 more which are at various stages on the drawing board. We also proselytize about our work. We published a book immediately on completion of the Murray Grove project, showing how we did it, giving away all our trade secrets and the research we'd almost bankrupted ourselves making. We got we were paid a standard fee for the project. The only way we could convince our client to do this revolutionary building was to say we wouldn't charge him a penny more, but we probably spent about 3 times the amount of time that we would have done on doing a traditional, I say traditional concrete frame solution. More recently, a couple of years ago, we published a book of 100 projects in the UK, not all of which were, only 7 of which were ours, as a global marketing tool for cross-laminated timber to demonstrate its move into the mainstream. And it shows a very wide array of buildings, building types, of scales, and includes many top names in architecture and in development and in construction within the UK. In fact, this was funded by the US Department of Agriculture, the Softwood Development Association, in order to help promote CLT in the US. So, talking about the drivers, why we're moving towards CLT, what's been going on. Obviously, the key one, which we've all talked about, is climate change. These are photos of obviously pre-COVID, the climate sit-ins in the City of London, which kind of brought traffic to a standstill a couple of years ago. I mean, now this is the change. We very much, for us, where we've been sort of preaching about this for many years, it sort of feels like everyone else is now on the pulpit with us, which is great. We're very happy about that. And I think, I talk about my architecture, but one of the things I'm most proud about creating in the last 2 years was actually this, which is a very simple comic strip, which is the most widely shared of all of the stuff we've done, most widely shared on social media. And we found many people have actually ripped it off and copied it for their own benefits. But it's very much that simple story that I told you in the first slide, set as a comic strip. It is that simple. One of the interesting things for us is the way in which we've managed to get our clients to use cross-laminated timber and become accidental eco-warriors is really by showing them the commercial benefits. In fact, the developer client for our first building, Murray Grove, said to us, "I don't give a toss about the environment. You can build it out of rubber bands if you like, as long as it's cheaper and quicker, I'll do it." And this is the point for us. And we've lectured a lot in the States. France is very big. It has a lot of political pressure to move towards timber building, but there's a real reluctance because in the end, and I'm not a great capitalist at heart, but in the end, the financial imperative has been what's driven the adoption in the UK. And with Murray Grove, we were able to demonstrate that we could build it in 2/3 of the time. We could build it for the same price. We could use less foundations. This building, which we completed 2 years ago, not that far away from the Murray Grove building, is directly above an underground railway tunnel, which meant we couldn't use concrete piles. We had to use a raft foundation, and as a result, the lightness, the weight, the reduced weight of the CLT meant we could build a 10-story building, whereas the engineers had told us in concrete that would only be 7. So our developer client got 121 units instead of something like 83. And that was the argument that we used for them. Again, not interested in any of the environmental benefits. It was the quicker, cheaper, more that won it for them. So these are the commercial benefits that we continue to use to persuade clients that this is the best way of building it. No mention of CO2. Sorry, my slide's slowing down. There's all in all, it's this is the reason why still a lot of our clients will use the material. But of course, one of the other key drivers, which we're very excited about at the moment, and particularly plays into our kind of post-COVID world, is health and well-being, which we were already talking a lot about before the pandemic, now becomes right at the top of the agenda. In the aftermath of the Spanish flu, the emergence of the Bauhaus and modernism, obviously these were things that were brewing, but were kick-started by this need for clean lines, this new understanding of how disease is caused by, you know, and is much easier to clean in these simple, clean, crisp surfaces. Again, it's more subtle. We understand more about medical issues anyway, but that health and well-being, the biophilia, the need for natural materials, and we're getting more and more understanding of the benefits in terms of living and working in timber, in terms of lower heart rates, better health, less stress. I won't go through all of this, but I think the slides will be distributed afterwards, and you can see that all of these points that now we understand that there's lower absenteeism in offices. Health outcomes in hospitals which have a large amount of timber in them are much better. We have people recover quicker, have less lying in bed recovery times. In school, there's less stress. There's a school near our office in Hackney that we didn't build, but was built in CLT for autistic children, and the head has said that the behavior of the children is remarkably improved by the timber structure. So this is the point I was making before. We are now at the point of a fundamental change, and CLT and mass timber construction is very well placed to move in with all the other drivers on and satisfy these needs for, as I said, natural materials and cleaner, more healthy workspaces. So this is an old slide showing the growth globally of cross-laminated timber. We are now at that tipping point where the curve becomes more vertical. All of the large producers in mainland Europe are currently in investment programs to double capacity. There are huge plants opening across the States, in Canada, in other areas of Europe, Eastern Europe like Estonia, in Australia. So this is now moving very, very fast. And for us, the real excitement is how does and going back to the title of my slide, which was that we're talking about a construction revolution. What is the next stage? I mean, timber is very much at its infancy, or mass timber is very much at its infancy. Much like concrete was 100 years ago. Concrete was, of course, an ancient material used by the Romans. The new reinforcing techniques suddenly opened up a whole new field of structural possibilities. And initially, the products were the use of it was very bespoke. And there was no consensus on any way in which you could build. Reinforcing was done with square bars, with oval bars, with round bars. There was no standardization, and we're now moving into that standardization. And my practice is very keen to be leading that charge. Housing, modular housing, as a way of taking more of the delivery of housing, particularly into factories, to improve quality, improve cost control. Cross-laminated timber is a very good vehicle for that, because it's very rigid, it's very simple to construct, it's very lightweight. And we're just finishing our first mass apartment building using these timber boxes. We can't see inside at the moment, but they're completely pre-finished inside with the wall finishes, etc. This is a pavilion we did for, in fact, the American Hardwood Export Council a couple of years ago, which explored some of these possibilities of prefabrication. All of the joints within the units, even though this is a play sculpture for a design festival, all of the joints and the way in which this was worked was part of a research project to further understand how we might simplify the process of building and joining boxes. And we're now moving more to building systems, and actually developing. We've got 3 or 4 projects where we're developing suites of components that can be used to create building systems for the very swift erection of timber offices and timber residential buildings. And these are some of the projects that are now on our drawing board. This is an office very close to our own office, built entirely from timber. The local planning authority allowed 2 extra stories because of the benefits, the CLT in terms of the carbon sequestration, in terms of that was offered. We're now looking at cladding systems using timber. And one of the other key things for us, this is a project I'll explain more about after this slide. We now have in New York a lot of and a lot of world cities, the concrete buildings of the 50s and 60s are now reaching the end of their life. The cost of demolition is almost, well, the prospect of demolishing large numbers of these is almost unthinkable. And the cost of completely refurbishing them is not necessarily justified by the capital value that, or the revenue value of the asset after refurbishment. So one of the projects we've been working on a 1960s end-of-life tower in London, this is the Euston Tower at the top of the Tottenham Court Road, is completely remodeling using timber to remodel the building, expand it both vertically and externally to create a more contemporary form, but add substantially to the floor space, which then justifies the expense of the complete refurbishment of the building and eliminates the need for demolition. And I think that as an exemplar project is something that should be able to be exported globally to similar buildings. This is a similar project that we're also doing in Amsterdam at a much earlier stage. And in Milan for Lend-Lease, this is a building system entirely devised for assembly. So this is a component-based office system that we're now producing, as it says, 100,000 meters squared, which is effectively 1 million square feet. And at the end, this is again another project up in Bergen, a project of housing built on a lake up in Norway. And I'll finish with a Latin quote. Unfortunately, our current Prime Minister, who I don't think, well, I'm not a big fan of, often quotes Latin. I'm not trying to emulate him, but this is something that was said by Cicero in 44 BC. And so I think it speaks for itself. I know I've spoken quite fast. I've tried to kind of fit a lot into my 20 minutes. I hope I haven't overshot. I think that's it.
Yeah, excellent job staying on time. Thank you.
So I'm not sure how I unshare now. Pause share or?
I think you just hit.
Right
sorry,
on
there
the
we go.
top.
I'm sorry,
Yeah.
there we go. Thank you.
Thank you, Anthony. It was excellent. We already have some questions, but we're going to first move to Howard and get sort of a local take on his perspective and his experience with Georgia Tech.
Great, thanks. Let me can you all see my screen? All right. Anthony, great presentation. And I don't know if you've been, one of the challenges with CLT high rise are the codes currently in the US. I know at the University of British Columbia, they did Brock Commons, which is a student housing, 16 stories, and I've seen it. And when they did the first phase of that, the fire marshal was uncertain about the structural integrity of the mass timber columns and required the owner and the architects to wrap them in fire retardant treated drywall. The second phase, they did not have to do that. But as we all know, probably on this call, that the structural integrity is better than steel. You know, the wood would just char on the outside and be fine. But anyway, I'll get into my talk here. So I'm sort of looking at it from a campus development. And so Anthony, a couple of these slides here are for you to show you where Atlanta, Georgia is. So we're in southeastern United States. There's Florida down there. And then, you know, we have drought issues. So issues related to climate, you know, drought is a big issue in Atlanta. We have tornadoes. We have light pollution. So obviously Atlanta being a metropolitan area, you sort of can see, you know, that hot spot there. And then apparently there are a lot of McDonald's in Atlanta and other major cities. And it's really quite amazing. as context, Georgia is a relatively happy state. We're not as happy as Montana or Wyoming, but we're more happy than other places. And then occasionally we get snow in the green zones, and here's Atlanta. So any type of snow, schools are canceled. So just a little context for everybody. So I'll start. So Georgia Tech is a public university founded around late 1800s. And this is an early photo. All the buildings are red brick and from indigenous red clay in Georgia. The sports field for baseball, track, football, soccer, it was all on the same piece of dirt. So Georgia Tech was a highly sustainable campus when it was first built, long before sustainability became fashionable. And then another historic image, there used to be streams that roamed through the campus. So that earlier building you saw was right there, sort of what's Tech Tower. But these streams over time got buried through in concrete pipes as development occurred on the campus. So when I was at Georgia Tech, we had a campus master plan, but we also had a standalone landscape master plan that really focused on the ecological and human landscapes. And we created this green donut that we called the Eco Commons, which is about 80 acres. The campus is 400 acres, so it's a pretty good percentage of the campus. And you begin to see these little blue lines of where those buried streams become visible again. In Atlanta, we have combined sewer systems. So sanitary and stormwater are all combined. It has to get treated offsite, and then it comes back out of the faucet. So how do we sort of reduce our demand on potable water for non-potable needs, and how do we protect the river, if you will? So when I arrived at Georgia Tech, probably not too dissimilar from a lot of campuses that evolved over time, the heart of campus was asphalt. And Bill and I were in grad school together, and you can park in front of any building you wanted to on campus. And that wasn't really a good thing. So we sort of, revision what the campus could be. And this is the same view. So that parking lot is now the central green space of the campus. There's a 1.4 million gallon cistern in the center of this green space that harvests water from about a 16-acre basin. That water is used to irrigate this entire area and also flush the toilets in this building that you'll see in a moment. So we're using non-potable water for non-potable use. So this is that building. So it's called Clough Commons. At the time, it was one of the largest LEED Platinum buildings on a college campus in the United States. It has an 85 kilowatt PV array, has a green roof, which we had never done before. The green roof is pretty spectacular place to study and just get some relief, pretty magnificent views. Before we built this building, I'm not sure where all these students were, but clearly they like coming through the building. And, it became a movie set in the movie called The Internship with Vince Vaughn and Owen Wilson, where they were Google executives. I don't know if anyone ever saw it, but if you did, in the very last scene, there's a little cameo with me and Rose Byrne, who is Owen Wilson's love interest at the time. But this is a building, this was actually our first LEED Platinum building. And we got federal stimulus money to build this building. And we called it the Carbon Neutral Energy Solutions Lab. And it's not so much that the building is carbon neutral, but the research that they are doing in the building will hopefully enable future generations to figure out how to do carbon neutral combustion, carbon neutral construction, things of that nature. But one of the things we did, it's a high base space, and in part of it, all the solar panels were technologies developed by a professor at Georgia Tech. He had a company called Suniva, And being a federal stimulus grant through the National Institutes of Standards and Technology, there was a Buy American clause. So that made it very easy. But in this high bay space, we did not air condition that space. We put in thermal heating in the floor, radiant heating in the floor, and where there were louvers down low, louvers up high, and then big ass fans. So, and I've been there in the summer where it's, 95 degrees Fahrenheit, and it's outside, and inside is about 78 degrees. And because you only really need to condition the bottom few feet.
Cold. I got a cup of coffee over here if you like it.
I already drink coffee, thank you.
Andrew, you may want to put yourself on mute. So, and this is another LEED Platinum building. It's a wet lab chemistry building that really sort of took continue to take these lessons learned and apply them. We developed this temporal forest in the front of the building. It's a future building site. Those trees were recently transplanted, and I'll show you where in just a moment. And now we replanted some new trees in that location. But access to natural light is really important. But one of the things that happens when you do development, sometimes you have to lose some trees. And I started a tree cycling program, not only with this site, but all over campus that, fallen trees through storm or disease, and had a stockpile of trees. And then I had some public policy students write a policy for the campus on how to tree cycle. Previously, all of these trees would just get turned into wood chips and mulch. But what we did, we cut down these trees, we milled them, and they became the stair treads and the benches in this 5-story building. So now the building tells a story about its sense of place. Which sort of leads us to the living building at Georgia Tech. So the Living Building Challenge, was started by the International Living Future Institute. And at the time, so the whole notion behind the living building is using, the metaphor of a flower and what would nature do. So it's regenerative, beautiful, it harvests all its own energy and water, it's pollution free. And so that's sort of the goal of the Living Building Challenge. We were fortunate to get a gift from the Candida Fund of $30 million. 25 was to build the building, and another 5 once it got certified for programming for the next 5 years. But the notion was to transform the building industry in the Southeast. Up to this time, there were only 12 full living building certified buildings in the United States. And they were either in the Pacific Northwest or the Northeast, but not in a hot, humid climate like Atlanta. So the Candida Fund was looking for a partner and felt that Georgia Tech, as a habitual builder, deeply committed to sustainability, would be a great partner to engage with. So this building sits in a portion of campus that we've developed. I mentioned earlier about this Eco Commons. So this is a part of that Eco Commons. Here's the footprint of the living building. And you begin to see some blue lines in here, which are those waterways that are now engineered and brought forward. And we created this performance landscape. But what we did, we had never done a living building before. We've done lots of LEED buildings, LEED Platinum buildings. So I did this ideas competition where we shortlisted 3 design teams, all of whom had members of their team who had done work on living buildings. And we did an ideas competition. We had students involved. We had other representatives involved from Georgia Tech and from the donor. And before we even made a selection, we talked about impact and influence. And before we even started anything, you can see, we had a global reach, even up into Canada, with team members on this through this ideas competition. And we set up these workshops over 2 days, 1 day per month over 2 months in each of the firm's offices. We wanted to see how they worked. We wanted to make sure the alpha dog architect wasn't dictating to the landscape architect or the structural engineer or the mechanical engineer or the civil engineer what is the right decision. It needed to be a very collaborative and integrated process. And we just observed this process. We did not ask questions, nor did we answer questions until after each round of these workshops, where we then provided written comments to all 3 teams. So we just embedded ourselves in their offices. And, you know, again, we had never done this. So we were on this learning journey as well. Concurrent to the project, there was a studio in the College of Architecture that they did the living building. And this is a design review. I was there. Members of the donor organization were there. And it was really fascinating that the students were working on a real life project and had this critical impact from and feedback from a lot of folks. But we have something at Georgia Tech called a Planning and Design Commission, which is an external advisory board that gets together once a quarter, and they're involved in the designer selection process and ongoing design review process. And all of those students who are working on this project in their studio were all invited to observe the interviews. And they were all in those workshops. And I know when I was in architecture school, I never got to sit in on an interview. And these students were the client to those firms. And it was pretty powerful. So again, so here we are. Here's this Eco Commons. This is about 8 acres. And here you see the Candida building right there. And just some visual eye candy that came out of this ideas competition and some renderings. Again, we needed to understand what the impact was. This solar canopy provides all of the energy for the building, and it's net positive energy. The building is net positive water. And those are the requirements of complying with the Living Building Challenge. Some more renderings. You know, while in Atlanta, Georgia, having a west-facing porch is not how you want to orient a building. We just felt that the orientation of this building to the Eco Commons was critically important. So in the southeastern United States, you know, porches are really, you know, communal spaces. And then there's a little roof garden. We have an apiary up here and it overlooks the Eco Commons. And you'll see some photos in a moment, but it's all, there's, you know, mass timber, there's some other wood structures and harvested wood, and some of that tree cycling that I talked about earlier. So in Georgia, the film industry is quite big. And normally these sets that are built, that material would just get thrown into the landfill. There's a nonprofit in Atlanta called the Life Cycle Building Center. We partnered with them to store this material for us. So all of the 2x4s were reclaimed from these, movie sets. And then we sort of built a mock-up of what that ceiling floor panel system would look like. So the 2x4s are the harvested wood. The structural engineer could not guarantee the structural integrity of those 2x4s. So we had 2x6s of Forest Stewardship Council wood. And then we worked with another nonprofit to do workforce development, to work with Skanska, who is the contractor, to fabricate these panels. And these panels were about 5.5 feet wide and 10.5 feet long. And this is just sort of an outer wrapping on that, that panel so they can transport it. You know, similarly, you know, because we have 200 buildings on 400 acres, we had another project going on where we had to replace a slate roof. So that slate was harvested and it became the wet wall in the bathrooms in this building. And those bathrooms are composting toilets. So it uses about 1 teaspoon of water per flush. So here you see some of the construction. You see the heavy timber column and the frame going up. And I think it's important to note that while it's heavy timber, you do have these steel connection points, and how those are detailed is critically important. Just another view, and here you see those floor panels getting ready to be staged and installed. And you know, something about being regenerative and playing it forward and amplifying impact. This is a group of folks from Nashville, Tennessee, this person here is a colleague of mine. He's the campus architect at Vanderbilt University. And they wanted to make a program called it Making Nashville Living Building Ready. So they came down several times. We went up there, educated them, and now they're trying to do some living buildings in Nashville, Tennessee. So here you see a few of the images. Equity is one of the petals. So having the ramp, right at the front door, and makes it accessible for everybody. You don't have to walk around to go find the ramp or the elevator. And then the framing, I mentioned that these panels are 10.5 feet long. Well, dimensional lumber in the United States comes in 12-foot lengths. So what to do with those 18-inch pieces that were cut off? So they became the stair treads turned on edge inside the building. So a few glamour shots of the building at night. During the day, very lightweight structure, sort of very sail-like, leveraging the use of steel to make the building as light as possible. The louvers that you see here, you think of yourself, when you go out in the rain, you put your raincoat on your outer layer of your clothing, not on the inner layer, where historically people might put, window treatment on the inside. Well, you've already brought in a lot of the heat gain, and it increases the heating loads of a building. And then the rainwater is captured from those solar panels, goes to these gutters, and there's a 50,000 gallon cistern that harvests that water. And then we worked with the Environmental Protection Division to turn rainwater into potable water, which hadn't been done in Georgia before. And then part of the project, I set up the budget where 0.5% of the construction budget was for public art. Again, sort of going on the same regenerative theme. This is an artist from North Carolina. His name is Patrick Doherty. If you Google stick work, you can see his work. He got volunteers. I was out there for 3 days with him, primarily him and his son who were down here. And, they fabricated this structure. They do these things all over the world. And all of this material was harvested from a place called Serenbe, which is about an hour south of Atlanta. And it's ephemeral, it's a short-lived piece, but it's really quite beautiful and very sustainable. And then, when we were under construction, this is the donor, this is Diana Blank. Those of you from Atlanta know Arthur Blank, so that's Arthur Blank's first wife. Candida is their 3 children, Kenny, Dina, Diana. So that's Dina right there, so that's how Candida came about. And then this was last week at the ceremony of the certification. It's the 28th fully certified living building in the world. And so here's Diana Blank, here's Dina Blank, some of their advisors as well. So, and it was done on Earth Day. So I set up the address of this building. If anyone's ever been there. So the name of the street is called First Drive, and the address is 422 First Drive, and 422 is Earth Day, April 22nd. And then here's some of the eco commons. You see the Candida building in the background. That piece of sculpture is back here, looking back. So this is a performance landscape that then will ultimately have a Blackwater reclamation component to it, where we will extract water from the combined sewer system, treat it, and it will serve a central plant that's a couple blocks away, and it will save about 50 million gallons of potable water per year. And then again, here's, during rain events, rather than this water being put in a pipe and thrown into the combined sewer system, it becomes visually exposed. So it becomes a research and educational and recreational amenity for the campus community. And then the last couple of slides, we were talking about carbon. So this is actually the last thing that John Portman designed. And it's a piece of sculpture, and it's made out of carbon fiber. And it was, it's about 40-foot tall carbon fiber structure. It was manufactured by a custom racing boat builder in a small town in Lincolnton, Georgia, near Augusta. It has LED lights, and it's kind of a cool thing. And John Portman's probably the most famous architecture grad from Georgia Tech after Bill D. St. Alban. And this is where I work now. So I work in a 200-acre Olmsted-inspired design park. And how do we sort of continue to advance these conversations in taking good care of our planet? I did a little RV trip back in October with my wife. This is a national park in South Carolina called Congaree National Park. So I guess I was just hugging the tree there. And so now that I'm the last person, so this is a perfect way to end this conversation with, for you to raise your hand if you have questions. So this is actually a tree that was carved. So it's a way to, prolong the life of a dead tree to create, maybe ephemeral public art. So I'll sort of stop there and, and then we could, I'll stop sharing my screen, but it does take all of us, we all live on this one planet together, and we need to cultivate behavioral change to make a difference. So.
Thank you, Howard.
Very nice presentation. There seems to be a list of questions in the chat log. A couple questions that come to mind is really some beautiful projects that were shared by both Dan and Howard. For Dan, I'm wondering about the off-gassing of the CLTs in London and the projects he's done in the UK. And for Howard, I'm interested in who's doing the black water system at GA Tech and the structural engineer that you worked with for the mass timber design.
Thank you for that, Andrew. And I think you were directing that question to Howard and Anthony.
Oh, am I? Sorry.
Yeah, and those are, I think, they're two most prominent questions we got so far. We do have a couple others that have come up.
So, Anthony, do you want to go first?
I mean, in terms of the off-gassing, it hasn't been an issue in the use of CLT. Most of the CLT we do seal the exposed CLT. One of the principal reasons we do that is we seal it we treat it for surface spread of flame, because that is obviously one of the fire issues. I know there's been some other questions on fire, but also with the spruce, where it's exposed, we have an issue of discoloration with UV light. It goes very yellow. So we put a treatment on. I think that deals with any off-gassing. It hasn't been where we've had. One of the pictures I showed when I showed all of our projects, there's a private home which was a single-story dwelling. It was all exposed cross-laminated timber, and it wasn't an issue. And we're talking about natural wood. I mean, the off-gassing, as I'm aware, a lot of the off-gassing from natural wood, like larch, actually have positive health benefits. We do, obviously, there is the adhesive, but the adhesive, the formaldehyde in the adhesive is at a lower concentration, I'm told, than in the wood itself. So, as I say, that hasn't been an issue. It may be that I'm misled, but we haven't had that issue. There may be different regulations in the US or perceptions.
Howard, do you want to address the other question there?
Yeah, so the structural engineer for the Candida building was Uzanin Case. Jim Case was the lead designer, and Jim's fabulous because he really understands beauty and design and really wants to challenge himself. It'd be very easy to for him to have put a 12-inch tube steel column out there, but he sort of looked at the compressive strength and tensile strength and figure out how to make it as lightweight as possible. And this team that was selected, it was Miller Hull and Lord Atkins Sargent. They were selected in part because of the beauty of the structure, but the other part and I'll get to the other part of your question in a moment. You know, the reason this team was selected, so we talked about replicability and regenerative design. It's not that, you know, someone else is going to take this design and put it, you know, on some other site in some other place, but we also wanted to create knowledge transfer. So Miller Hull and PAE engineers out of Portland and Seattle, they worked on the Bullitt Center in Seattle, which was, I think, one of the first living buildings in the country. And then they teamed with Lordak and Sargent and Newcomb and Boyd. So they collaborated really well. So now in Atlanta, Georgia, and in the Southeast, there's a knowledge base of subject matter experts, architects, engineers, and contractors who can now help other clients pursue living building challenge opportunities. And they may not pursue full certification. They may choose to just do some pedal certification. The other thing, you know, when about a week after the ideas competition, we made the selection, I had all three teams do a public presentation. And no one had seen the work of their competitors. And I remember Phil Harrison, who's the CEO of Perkins and Will, you know, they were all blown away by the quality of work that everyone had done. But Phil said, you know, I can't unlearn what I just learned going through this ideas competition. And they've had principal retreats, you know, and Perkins and Will is a big firm. And one of their design principals, you know, they were at a, you know, they were meeting in, you know, wherever, Canada or somewhere, and he showcased the work that he had done. So, you know, they're sharing their experience of doing the living building with other folks within their firms. And, you know, they'll go work for, you know, other clients around the world, hopefully, and, you know, transport some of this knowledge. The other question about this the Blackwater reclamation. So we put in the infrastructure. There's a company that worked with called Sustainable Water out of Virginia, Richmond, Virginia. So they're the ones that worked at Emory University on their water hub. And before Emory even did their, you know, took their first step, you know, we met with folks from Georgia Tech, Emory, and Spelman. And, you know, we were trying to figure out what's involved with this Blackwater reclamation. And we let Emory be serial number 001. And, you know, there are things that they learned that they would do slightly differently. Georgia Tech's been a little more methodical, but we have a placeholder in an adjacent building for this, our own water hub to exist. But we did all the data analysis and all the detailed analysis of, you know, how much capacity is in this combined sewer system. Fortunately, we have 3,000 beds upstream of student housing. So we knew we had a guaranteed flow of appropriate waste.
So we still have a number of questions, and I think we have about 20 minutes. I guess, Bill, if that's good with you, to get through some of these questions. I think Anthony's going to have to be off at 12:55. And I see Andres Villegas. I'm gonna hope I'm saying your name correctly. He had a question about the a couple questions, but you know, the comparison of the cost of mass timber, and then, you know, the question of sustainability of using wood, which is I guess an interesting question. But could you address those a little bit, Anthony?
Dan, if I could add a little bit of clarity to that, I apologize. In a small group here, I'll jump in. It was really more of a progression of the issues that we have to, the humps that we have to get over. And so whether it's people in other industries or with other motives or other things that they want to represent that are directly in conflict with mass timber. You know, when you place mass timber in a project, you're replacing something else. And so those folks obviously have the interest. And so we've had to answer questions about fire. We've had to answer questions about sustainability. We've had to answer questions about cost, all of these things and humps that we can get over. But how do you see that evolving? What are the questions that you're dealing with right now that you weren't dealing with a year ago? What will those questions be a year or two from now? What do you see that coming forward, so that Europe's always ahead of the US, so maybe we can learn and get it and be ready to answer those same questions?
Well, I think, I mean, you make the very good point that, you know, we're pushing out other industries, and they they push back. And I think the concrete industry has taken a very adversarial approach to mass timber's encroachment into their natural market. And I think there has been, I mean, one of the key issues is fire. It's very easy to point at a bit of wood and say it burns, it's not safe. We know that steel melts in fire, whereas the timber chars, as Howard was saying, and protects itself. So you know, and the issue is that the industry is still very fragmented, not only, you know, that globally in terms of getting all the producers speaking together, but also the vertical integration between the forester to the specifier. And we have had success in the UK and in Europe, and actually putting together and getting building up a database of testing, because that's the thing we have to test. You know, the concrete's been tested in situ, and you know, for a century, we need to catch up and close all the gaps in our knowledge so that we can provide adequate data. I mean, we know, I mean, the simplistic view that timber burns and chars and protects itself is not enough now. I mean, we have the rather sad prospect in the UK as a result of the Grenfell fire, which was obviously in a concrete building with an aluminium cladding. Timber is the main industry that's been hit by this with very broad legislation rushed through that has actually impacted on the perception of mass timber in the UK, and that is something that has been problematic for us, and it's created additional. Not only has it impacted the use of it, it's also impacted the reputation of it, and we're having quite a lot of work on that to push back. But as I say, it's basically it is that is through testing. The issue of again, one of the other key things that the concrete industry has done is sort of shows pictures of harvested of flattened forests and says, well, this is, you know, and questions the sustainability. There's some fairly cheeky ways in which they measure carbon to show that timber is more carbon intensive, because of course it's not, the jury's still out on whether you should include the sequestered carbon in the calculations, which I think is, for me, is a no-brainer. But I think there's, you know, that kind of pushback. Obviously there is a problem if we're creating a massive growth in the use of CLT, if that led to monocultural forests that are which have, you know, devastating ecosystems, that would be a problem. So there needs to be, I mean, that whole supply chain needs to be analyzed and assessed. There's a lot of work. I mean, yesterday I was on a meeting hosted by the World Economic Forum, and actually dealing with this exact question: how do we deal with this? That you know, from seed to finished product, how do we audit that carbon trail and make sure that everything is being counted in a rigorous way, so we can push back against that perception. Cost is, I think, the last item you mentioned, and I think cost, you know, it's supply and demand, isn't it? I mean, I think what we've found is that one of the problems we have is we'll have a cost consultant who'll say, well, I know that when I'm doing a rough price on a concrete building, when I want to price the frame, I'll allow £170 a square meter. I don't know how that translates into dollars and feet, but they'll say it's £170 a square meter for the concrete frame. They'll ring up the CLT producer and say, how do I price your CLT? And they'll say, well, it's about £250 a square meter, gross internal area. So they'll go to the client and they say, well, look, it's going to cost you £80 a square meter more. You know, this is crazy, but they're not factoring in the fact that includes external walls, that includes internal walls, it includes a level of insulation, it will include stairs. There's a reduction in the cost of the foundations because there's a reduction in the building weight, and the fact that the building will get finished quicker. So again, it's producing enough data to reinforce the messages that we know are there, and I think that's what, as a global industry, we need to be pushing towards, so that we can push back against misinformation and lazy thinking.
Yeah, I'll add a few things. And Andres, you and I chatted about this before. You know, so the Candida building at Georgia Tech, there's concrete, you know, there's steel, there's wood. You know, those, you know, wood floor systems have concrete on top of them. You saw the structural steel columns, the steel connections, there are steel trusses sort of pulling, keeping the building, it's a hybrid solution. When we did the ideas competition, all of the teams sort of did that analysis. They said, okay, if we do it out of heavy timber, here's what it would be, here's the carbon, here's some cost benefit, pluses and minuses, if it's concrete, if it's steel. And maybe I'm in a better situation than perhaps some of Anthony's clients, where we're an educational institution and we're willing to take some risk. We were willing to not pay the lowest price possible, that we're building for 100 years or 200 years. So our mindset, it could be different than a developer doing, student housing or low income housing where, every nickel counts. I think the timber industry in Georgia has, and you and I have chatted about this as well, shot themselves in the foot a few times. So we can, we're the biggest, timber is one of the largest industries and economic engines in Georgia, but no one wants to do FSC wood. They lobbied the previous governor to not allow LEED certified buildings on public land or publicly funded buildings. So the whole notion of sustainability, it could be it could exponentially grow the timber industry in Georgia, but perhaps not all of the factors were taken into account. And I think, as Anthony pointed out, like we've prefabricated those floor panels off-site, and that gets erected a lot faster than pouring concrete, waiting for the concrete to cure, putting up all the shoring. So the structure gets erected in a fraction of the amount of time than if it were poured in place concrete. So, you have to look at the entire package of costs, and, smaller structure, smaller footings. And yes, it may cost a little bit more. I think we were maybe 10 or 15% more overall. One of the buildings that I showed you, the engineered biosystems building, was a 218,000 square foot building. We built that for $400 a square foot. The Candida building, and that was a LEED platinum building with wet chemistry, so fume hoods and all of that stuff. The Candida building, for the total program, because we had the porch space, which was programmable, we had the roof, that was about $400 a square foot. But if we had about 10,000 square feet of unconditioned program space. If you include all of the space, only the conditioned space, it was about $500 a square foot. But those outdoor spaces are programmed. They're outdoor classrooms, and so it depends how you do the math as well.
Howard and Anthony, I really I like Holly's recommendation or her idea that we partner with the London chapter in the future. I think there's just, again, so much that's happening in major cities around the world that, again, can be helpful to us, maybe not only in the science and the policy, but also in the public acceptance and understanding of climate goals and what kinds of actions. Can you tell me a little bit about, from your point of view, how important is, and let's, on this particular issue, supportive building codes, public policy, like, more towards encouraging, sustainability versus throwing up roadblocks. And I think, I don't know the latest on whether, what's the height and things that can be built with mass timber in Georgia. But again, is this still something that is legally being challenged or anything like that? Or are we kind of, is it just open now for the market to build this?
So I think a lot of it is open for the market. So, we know in Atlantic Station in Atlanta, Hines built a heavy timber building, but I think it's only like 5 or 7 stories high. So I think there's some code updates. And as Anthony said, testing that needs to be done so that the code officials can feel comfortable doing fire testing to say, yes, this is, the structural integrity is good and it's actually safer, as safe or safer than other building materials. I think so it's just about creating that demand, but also the interest. One of the things for us when we had the certification ceremony last week, Diana Blank got up, turned around and told the students, this is for you. So, we deliberately set up that building where it was, I guess, a non-denominational building. So it would have been very easy for the College of Design or College of Engineering to have all their classes in there. But we work with the registrar's office and the provost's office to say, we want every student at Georgia Tech to have an opportunity to have a class in here. So introductory science classes are in there, and they're using clean, green chemistry in what they're doing. There'll be math classes in there. So take your, Calculus 101 in there. So everybody will have an opportunity to experience this building. They will graduate, and hopefully they'll remember, they won't remember what they learned in calculus, but hopefully they'll remember, wow, this is a cool building. It was made out of mass timber, or it's net positive energy.
Anthony, similarly in London and in the UK, is there incentives to be building more sustainably, or is it just kind of left up to the market to decide? Or is it on an equal footing right now?
No, I mean the challenge, as I said, I mean all of the sustainability criteria are geared towards operational carbon, and we're still not. There's no legislation supportive of the measurement of embodied carbon, so it's not yet. That's not really helpful from a national. That's from a national point of view, and as I said, from a national point of view, we are having pushback because of new regulations coming in that for example, prevent the use of any combustible material in the external wall of a building above 18 meters, which is about 7 stories, which therefore includes CLT, since wood is deemed combustible, even though you'd have to put a lot of fire load to get the thing started. So there's, but I mean, on a more local level, I mean, we have a lot of, and the timber industry is having success in speaking with local authorities who are including sustainability criteria more within their planning system. So when they give approval to a building, we have the planning approval, which is, yes, you can build that type of building. Then you have the building regulations, which is to do with code. But the planning approval, there are various local authorities who are insisting on sustainability criteria that does favor timber. But of course, again, we have a concrete industry who are resisting and using any means possible to hold them at bay. So, I mean, that's just part of the process. If I invented a car that ran on water, you can bet that I'd be tied up in legal battles with the petroleum industry for the next 5 decades. So that's the issue. I think. Yeah, I mean, the thing to remember is that we are just, there's so much that we have to do as an industry, and I think the global network is really helpful. And I think we've been linking with groups across the globe because we can learn from each other and share information. There's an interesting one of the other issues, in fact, which I meant to bring up in the earlier question was one of the key issues, also water, which doesn't get thought about often, but of course, water penetration, you have timber can, if water management, particularly rainwater, you know how wet the UK is, but it's not rain is not exclusively ours. Water, if it gets to the timber, you can get rot. But then that was a case, I'm told that Le Corbusier, if it hadn't been for the outbreak of the Second World War, Le Corbusier would have been bankrupted by the number of cases against him for all the leakage in his buildings from water, and the war saved him. So Maybe, but you know, there is a huge potential for that to, if not addressed now, for that to become a major issue for us.
Yeah.
But
Dan, I'll share one thing. So there in the US, there's something called the American College and University President's Climate Commitment. And there've been over 700 signatories of this climate commitment. And I was able to convince the president at Georgia Tech back in 2007 for us to sign it. And the notion was to be carbon neutral by 2050. You pick your own date. And we knew that we would never be able to be carbon neutral based on the technology that was available today. But maybe in 10 or 15 years, we might be. And any research university or any medical school will never be able to get there with fume hood technology as it exists today. But again, you know, we knew that if we would sign this and begin to move the needle, we'd be in a much better circumstance than if we did nothing at all. And then, you know, to sort of talk about this sort of global network, I'm a part of a group called the Association of University Architects. And there are about 150 of us, primarily in North America. We get together every year. And presentations like I just gave today, I've shared with all of them. And universities really have the greatest opportunity to be at the forefront of change because of their educational research missions and because of their longevity of what they're building and you know their growing interest and commitment to sustainability. You know, I mentioned University of British Columbia. They're probably, you know, they're ahead of Georgia Tech for sure. You know, doing high-rise CLT. You know, and some people on this call are aware that in Dothan, Alabama, there's a CLT plant that just, you know, opened up a few years ago. Well, why isn't that in Macon, Georgia? You know, so now we have to, you know, we're not going far to get it. It's 4 hours away, but 3 hours away. But why aren't we doing these things in Georgia? And maybe it's a supply and demand issue there.
So I know we're gonna, Anthony, you need to be off in 2 minutes.
I'm sorry. I'm sorry. I have a son who needs collecting from school.
Well, first of all, we would just want to be very thankful for your time today and having an international expert with Howard here as our local expert on the call, and it's just been very, very helpful. And we really would like to continue this discussion with your colleagues in London. Maybe we can get a broader and larger group next time. It'd be great. Bill, do you have some follow-up comments or?
No, this is great. I mean, it's an area I really appreciate the depth of knowledge of all three of you, and I'm excited about going forward. Some of the and some of the other people in the room know that the laws are changing. The IBC has been adapted for 2021. It's going to allow you to go up to 18 stories with mass timber. So the codes are changing. You got to adopt them state by state. I sat on a panel or presented to a panel that's weighing whether Georgia will adopt that. And 12 stories and exposing it. We go from 12 to 18. You got to still cover it with the gyp board. So we are moving the needle in Georgia in terms of mass timber. But I also think I've known Howard probably too long. There's a whole nother story that Howard will tell you, and it's probably another some about the operational side of carbon. You know, how do you operate a building to have a zero carbon impact? And that's a big story where somebody sitting in Howard's seat has had told me many things over the years on what's going on, what that has changed the whole institutional operations. You know, you can't plug in your cell phone to charge it. Is that one of them? I don't know. Or the bees are making the energy. I don't know, but it's a challenge, and you really have to think through the way you're doing everything. And so I'm honored that we had the Anthony from London's office, and we're actually all three of us are collaborating. I'm not going to talk about it. All four of us are collaborating on something that should show up within the next 6 months. So this is exciting times, and I appreciate the ability to work with all you guys. And I really appreciate your time today for our LAI chapter, and I appreciate the idea of a series, Dan.
Absolutely. And, you know, I think together with Holly and LAI colleagues internationally, and then our local contacts, I think we could really put together a lot of good programs around, again, around these different areas of climate, sort of trying to address our climate goals and strategies. So I look forward to it.
Take care, man. Thanks, everybody. Have a good week.
Howard, thank you. Thank you, Anthony.
Bye.
Thank you.
Bye.